Hi, friends. Welcome to our Ask Me Anything today. Some people who've sent questions in advance, I'm going to switch to those and get those out of the way, and then we'll go through any questions that have come in on the comments. So thanks all for being here. We're just going to have a good time. All right. So question from Christine. What developments in our understanding of plants are you personally most excited about? Oh boy, Christine, this is a good one because over the last couple of years, I've been really excited about our developing understanding of the rhizophagy cycle and how plants absorb nutrients from living microbes. And our understanding of that continues to grow, continues to develop. We are learning more about what happens inside plants, and as I'm persuaded that as we learn more, it's going to we're establishing the foundation for a completely different type of plant nutrition, where we now understand that some of these nutrients that were thought to not be flow-mobile, such as calcium and boron that don't move around inside the plant very much, can actually move around when plants are getting nutrition through the rhizophagy cycle. And the other thing that we're learning is a remarkable degree of the plant's capacity for nutritional homeostasis, where they can self-regulate. They really can be in charge of their own destiny and self-regulate the amount of nutrients that they want to absorb and that they permit to move into cells, as long as they're provided with nutrition from this rhizophagy cycle process. So I'm pretty excited about that. There's going to be a lot of information coming forward on that over the course of the next couple of years. Let me see. There's a couple other questions here. A question from Terry. I know you said you can prevent aphids by getting the plant sugars balanced. Could you go over that? I have a greenhouse and have been struggling with aphids. So in short, if you have aphids showing up in plants, you will have a combination of three things. Or it can be, there's three major driving factors here that are three major possibilities. Possibility one is that you have high levels of chlorides. So if you're irrigating with water in a home greenhouse environment setting, if you're irrigating with water that is going through a water softener, you might be getting excessive levels of chlorides. And in a commercial field setting, when we're looking at sap analysis, we know that when we have chloride levels that are greater than total nitrogen, we have very high aphid susceptibility and insect susceptibility in general. So that's one possibility. The second possibility is that you don't have enough sugars in the plants. And this could be a result of having a week or several weeks of cloudy weather and not a lot of sunlight. Could be a result of imbalanced nutrition that's leading to not having good photosynthesis. The third possibility is that you have excessive levels of nitrates, and the nitrates are not converting to complete proteins. So to solve possibility number three, you need to address magnesium and sulfur and molybdenum and sometimes boron. Photomag contains this combination of nutrients, so you can buy Photomag on the AEA website and use it for that purpose. Or you can, if you can access them individually, you can also try them individually, although that's unlikely to be as effective. For possibility number two, if you have poor photosynthesis, and that's even possible, you might be getting good sunshine levels and still not be producing good levels of sugars. And that can be because you don't have enough manganese, or perhaps you don't have enough iron. And this would be a location or a time to put on a foliar application of our macropack and micropack combination. When we do that combination, we try to address all of the nutrients that are needed to drive strong photosynthesis to elevate sugar content, even in challenging environmental conditions. So that's how I would approach that. Let me see here. A question from Alex. My question is regarding potassium fertility in a corn, soybean, wheat rotation. We supply the majority of our fertility with layer chicken manure, which is relatively low in potassium. According to the universities, our removal is greater than the additions we are adding with the manure, and they would recommend we supplement with potassium chloride. Please don't. I've seen the potential drawbacks of potassium chloride on soil and plant health and would like to avoid if possible. Awesome. What are cost-effective alternatives to potassium chloride? Also, Mulvaney's work at Illinois suggests we don't need to supplement potassium fertilizer in some cases. Besides a standard soil test, what should I do to monitor this? Outstanding question, Alex. You've really been doing your homework. So, first of all, answering your first question, operating under the assumption that you do need supplemental potassium, you can replace potassium chloride with either potassium sulfate or with KMag. And our experience has been that you can replace potassium chloride with potassium sulfate, not on a unit for unit basis. Don't try to replace pounds of K with pounds of K, because potassium sulfate is quite a bit more expensive. This is a challenge for a lot of growers. And so our approach has been to replace dollar for dollar, replace the amount of money spent on potassium chloride with potassium sulfate. And we actually get a greater crop response from the potassium sulfate in terms of greater potassium absorption as measured on SAP analysis than we do with the potassium chloride, even though it's only 50% K2O instead of 60%. So that's the one idea for you to think about. But to your second question, which I think is the most important question, I don't think you should assume that you need additional potassium. Instead, actually measure your crop. Use SAP analysis to measure, does this crop actually have enough potassium, particularly later on during the grain fill period. If you are measuring that you have enough potassium, then why would you add more? And some would make the argument that the reason for adding more is so that you're not depleting your soil. All right? To answer that question, you need a less common type of soil analysis that is called a total digestion analysis. You can get a total digestion analysis from Midwest Labs, Ward Labs, Regen Ag Labs, probably others that I'm failing to mention. But when you conduct a total digestion analysis, it measures the total of the nutrients that are in your soil profile, the top 6 inches, or however deep you're measuring. And all of a sudden, in many Midwestern soils, you will discover that your total potassium levels in your top 6 inches might measure 10,000 pounds per acre or 30,000 pounds per acre. It can be some very significant potassium levels, and that's in the top 6 inches alone. So for those who want to argue that you're going to deplete your soil levels of potassium, well, that's if you completely disregard the subsoil. If you just look at the top 6 inches, you might deplete your top 6 inches of potassium in maybe 400 years. And if you include the rest of the subsoil zone, it will be measured in thousands of years in many cases. And so so I'm not necessarily disputing the need for nutrient cycling and nutrients being returned to the soil through manure and so forth. But I am suggesting that we shouldn't be thinking of it in terms of a short timeline, in terms of a few years or maybe even a decade or two, that we have much longer time horizons that we can work within, and that we should be thinking about it in that way. All right. Other questions that have come through. Question here from Matthew. When terminating a cover crop, is it, and you're looking at a crop that is tomatoes, is it best to chop and plant straight away for max biological activity, or to allow the roots and biomass a few weeks to decompose before planting the main crop? Matthew, it's my opinion that the answer is it depends. It depends on the carbon to nitrogen ratio of the cover crop that you're incorporating. It is possible to have a decomposing cover crop if you have large amounts of biomass. It's possible to have a decomposing cover crop that will temporarily pull nutrients away. The microbes decomposing them will pull nutrients away from the growing plant. But if you have a narrower carbon to nitrogen ratio, and if you've actually incorporated the cover crop into the soil, Generally, my preference would be um, I noticed you mentioned terminating. You didn't necessarily say to incorporate, but if the soil is being tilled, I would prefer to immediately replant back into it so that we have a living root system and that microbes can immediately recolonize that root system. And you get a better carryover effect of the microbiome into the next crop. That would be my preference, is to immediately recolonize the soil and provide a pathway for mycorrhizal fungi and so forth immediately after tilling by immediately replanting. Now, if you are just terminating, let's say roller crimping and so forth, um, in some cases you can let a couple of weeks go by and then replant without any negative effects. But if the soil is being tilled, the sooner you plant it, the better. Um, Let me see. Other questions. I saw one question pop up on my screen about 4-H foliar blend. If you have questions about that, if you go to our website, in the last year we've launched MacroPack and MicroPack, and those formulas are a significant improvement on the 4-H foliar blend and planter solution. So these products are intended to be kind of a two-part combination that covers a lot of bases. Question from Brian Clark. What would you say would be the critical times for boron in fruit and nut tree orchards? Oh, Brian, you ask an awesome question. And um, we're constantly learning more about boron and the tremendous positive impacts that it can have when it's well managed. So the critical times are whenever you need calcium, you also need to be addressing boron. So the period with peak reward, when you get the greatest crop rewards, are really kind of twofold. They are one, during the cell division stage, immediately after pollination, so starting at flowering and through pollination. The second stage is through fruit fill or nut fill or grain fill. So when we're moving carbohydrates into the storage sinks, into the fruit or nuts. Those are the two periods where we get the greatest yield and quality response from boron. Now, the follow-up question is, when should you apply it in order to have it available at that moment? And if you are applying it to soil, let's say you have, this can be a pelletized boron, it can be even soluble, 20% water soluble boron. When you apply it to soil, you should expect at minimum a 45-day release curve, and generally what we're observing is about a 60-day release curve. So you actually need to, if your pathway is with a soil application, and there's a bunch of assumptions here. If you have good moisture levels, good biological activity, you need to apply it 60 days before the crop needs it. If you're applying it as a foliar, obviously you don't have the need for that 60-day window, but you do need to then put it on as a complex, where you have complex boron that can be applied to the leaf surface and that is phloem mobile and can move around from the leaf into the fruit or the grain or the nut or wherever the plant needs it. All right, question from John. Hi, John. We've discussed nitrogen applications causing an instantaneous growth response in the absence of increased carbohydrates, as if a plant growth regulation effect, with the understanding that plants are exuding a large portion of their sugars to the roots. Is it reasonable to assume this response is actually the plant repurposing those sugars to growth because the plant has completely stopped exuding them? Yes, is the short answer. The other thing that I think we often miss thinking about is the effect that nitrogen has or can have on the root system. Not only it's as above, so below. If you have a plant that is that is susceptible to insects because of nutritional imbalances, if it's susceptible to insects in the crop canopy, then it's also likely to be susceptible to nematodes and insects in the root system. And similarly, if you are getting a growth flush at the top of the plant because of the way that you're managing nutrition, you should expect to see a similar root flush below the soil surface as well. So what can happen, and what you're asking about, John, if I'm understanding correctly, is that um, even when the top part of the plant doesn't seem to have a lot of sugars, when you add nitrogen, it will it can move sugars and pull sugars away from other parts of the plant in order to support that growth. So it can pull sugars from fruit, and it can pull sugars from roots and repurpose them to drive the growth that the nitrate addition might be signaling is beneficial or is required. Question from Jesse. Um, has there been specific research on whether inoculated seed with mycorrhizal strains has shown that they're able to sustain throughout the year? Or is it better to try to activate and awaken local mycorrhizal spores? Um, and Jesse, there has been a lot of research on inoculation, um, and to verify that they successfully colonize and that they remain in the soil system for an extended period. There's a lot of research that you can find quite readily on that topic online. And in my opinion, it depends a bit on your soil context and how your soil has been used historically. But if you have soil that has had a history of a lot of fungicide applications or intensive tillage, then I would highly recommend using a mycorrhizal inoculant. And even, even in soils that perhaps have not been as disturbed, BioCoat Gold is one of our most popular products today. It gets used on millions of acres for the very simple reason, the very good reason that it delivers results consistently. Like you can easily observe the results. And we have to there has to be some assumption, I think, that if that inoculant is delivering those results, even in soils that are perhaps not as degraded, um, those results are coming from somewhere. They're coming from the mycorrhizal colonization or from the other microbes that are being inoculated as well from the other bacterial inoculants. And so um, the idea of activating what is already in the soil is when we look at the landscape of regenerative agriculture practices and the tools that people are using that are being very effective, there is the particularly in very challenged environments, very arid environments in Australia and so forth, there is this prevailing consensus that it's not enough to just rely on what is in the soil. People are adding compost extracts, compost tea, worm tea extracts, microbial inoculants, mycorrhizal fungi. The list goes on of the things that people are adding, and they wouldn't be adding them and they wouldn't be talking about them as foundational and so important if they weren't getting the responses and weren't getting the crop responses. So I think it's not enough, in my opinion, to just rely on what is present. Question from Cole. Hi, Cole. When using the nitrogen efficiency protocol in corn, what is your preferred application method? Wide drop right next to the plant, drop in the middle of the row, or knifed in? At higher rates, 120 pounds of N, should I be concerned about volatilization, or does the NEP complex it to the point of that not being an issue? Well, the accurate way of saying it is that the nitrogen efficiency program complexes it to the point where it reduces volatilization. But I wouldn't be comfortable saying that it 100% removes it and remediates it. And of course, there's a lot of environmental context here that goes into this question. But the ideal, it's okay to use wide drops or to drop it in the middle of the row as long as we have good soil moisture levels. Because with good soil moisture, we can have good biological activity, and that will tend to activate and tie up a lot of that nitrogen into microbial cells fairly quickly. But if you have dry soils, don't have good soil moisture levels, or if you have bare soil exposed to the sun, then I would suggest knifing it in as being the ideal. Get it down into the microbially active zone. That's where you're going to have the greatest nitrogen use efficiency. Question from John. Um, how do we change the soil microbiome from manganese oxidizing to manganese reducing? Well, there's there's two pathways, John. First rule is stop doing harm. So first, let's stop putting or using management practices that have an oxidizing effect. Let's stop um, tilling our soils, adding salt fertilizers. Be cautious with limestone applications. Let's be careful with the things that have an oxidizing effect. That's part one. Part two is changing the soil microbiome by using cover crops or crops that have their associated microbiome has a net reducing effect. Um, so I've talked about this in some of my other webinars. This information is available and is out there. But if you want to change the microbiome, the pathway to doing that is to change the plant species mix that you are growing. You change the plant species mix, and the microbiome changes, and that will have an effect on increasing manganese availability. Question from Ortega. I always heard that in order to produce secondary metabolites, plants need to be stressed. But listening to your podcasts, optimal nutrition produces the same effect. How? It's a good question. I have this slide that I've produced. I've talked about this concept to wine grape growers on several occasions, and um, I want you to imagine a a bell curve or a curve chart, and we'll start on the left. On the vertical axis, we have a scale of photosynthetic efficiency. So let's start at the bottom. Let's say where we start is with plants that are stressed. Plants that are stressed either with water deprivation or nitrogen deprivation, phosphorus deprivation. And plants that are stressed will be at low levels of photosynthetic efficiency. They'll have 5%, more than 5%. Let's call it 10% photosynthetic efficiency. I'm going to bypass the curve chart. I'm just going to give you an illustration here. So at that low level of photosynthetic efficiency and at that level of stress, you have a plant that has a limited amount of biomass. If you're growing sage for essential oil, this is a common practice for crops that are oil producing crops, is to deliberately stress them so that we have limited biomass and higher concentrations of plant secondary metabolites. The prevailing wisdom is that when you provide the plant with whatever nitrogen and phosphorus and water it requires, you end up with a plant that has larger amounts of vegetative biomass. In other words, you've moved photosynthetic efficiency from 10% up to, let's say, 15%, maybe as high as 20%. And you have larger vegetative biomass, but a smaller concentration of plant secondary metabolites. And that is the case. We know that to be true. But that's generally been where the conversation stopped. And there hasn't been the realization that actually 20% photosynthetic efficiency is not the ceiling. We don't have to stop there. If we continue to ramp up photosynthetic efficiency and we go from 20% up to 40%, and particularly when we associate these plants with a supportive microbiome, now you get even more vegetative biomass than you do at the 20% stage, but you also have the highest concentrations of plant secondary metabolites. In fact, you can have higher concentrations of these phytonutrients than you do with the stress plant. Also, not only do you have the highest concentrations, but also the profile is going to be slightly different. A stressed plant produces a particular phytonutrient profile, whereas a plant with optimal nutrition will tend to have a slightly different profile of phytonutrients. And usually, that slightly different profile means better flavor and better aroma. This is when you actually start Instead of growing grapes on a vine, you start growing wine on a vine that is contained in a grape package. But the flavor profile of those grapes completely changes. They begin tasting like wine instead of tasting like grapes, which is some of the comments, the feedback that Greg Pennyroyal has reported from their harvesting crew. Is the harvesting crew says these grapes taste like wine. So it's possible to change the secondary metabolite profile when you have optimal nutrition. Yes, absolutely. It's a great question. Question from Craig. How effective is foliar feeding cover crops to ensure adequate micronutrients for the following crop? Craig, it's very effective. It's more effective and less expensive than almost anything else that you can do. In my blog several years ago, I wrote a blog post about an experience that we had on an alfalfa farm, um, where 2 foliar applications produced an additional 3/4 ton biomass yield on a single cutting, on the third cutting. And when you look at the data of cover crops and foliar sprays, if you put on a foliar application of, I don't know, I'm making it up here, a quart of rebound manganese, the quantity of manganese that is added to that crop is measured, it's tiny, it's measured in grams or ounces per acre. But when you look at the quantity of manganese, if you measure the crop on and you calculate the amount of biomass that's out there, what the dry matter biomass is, and the manganese concentration that it contains, and you do the math of what the quantity is of manganese that is in that crop, it's going to be significantly bigger than the amount that you applied. In many cases, it can be an order of magnitude bigger, 10, 15, 20x bigger than larger than the quantity that you actually applied. And that is true for the trace minerals. It's true for, you'll often, in fact, in this alfalfa scenario that I mentioned, we put on a foliar application and we got like 50%, if I remember correctly, 50 to 60% increase in calcium content, in spite of there being 0 calcium in the foliar spray. So working with cover crops and their photosynthetic engine, you can greatly amplify the effect of any product that you put on. And now you have all of these bioavailable nutrients available for the next crop to absorb. You know, years ago, it's now, I don't know, probably 15 years or so, that Chef's Garden here in Huron, Ohio was one of the early customers and growers that I spent a lot of time working with personally. And they started foliar feeding their cover crops. And that made a lot of sense to me because they're a high value fruit and vegetable production operation. And there is the economic means and the wherewithal to justify foliar feeding cover crops. But then a couple of years ago, I was at an event in Nebraska listening to a panel of farmers describe their approach to nutrition management and agronomy management. And Brian McGarren, who I've hosted on the podcast, said something that really struck me as important to think about. He said, my economic success on the farm is not determined by how well my cash crops do. It's determined by how well I do with my cover crops. It's the cover crops that determine my economic success. And what he was communicating is that if he did very well, if his cover crops did very well, then he had such a large nutrient reserve to provide available nutrients for his following cash crop that his input costs were extremely low for his cash crop. And now, and Brian went on to say, I'm not sure if he was doing it then yet or was just talking about it. I'm not sure where he was on his journey exactly with foliar feeding, but he said something to the effect of, I can't afford not to manage my cover crops. I can't afford not to feed my cover crops and to make sure that they're doing very well, because it's the cover crops that determine my overall financial success. And this was striking to me because unlike Chef's Garden is high value fruit and vegetable crops. Brian is growing commodity corn and soybeans. And so it's the opposite end of the spectrum from commodity pricing perspective, very tight margins and so forth. And so all of a sudden, it was a different perspective on the prioritization and the value of cover crops. Question from Tony. We hear from all the soil health experts that glyphosate damages soil biology, but I can't find anyone that can be specific about how much damage is done. As farmers transition to regenerative practices, it would be very helpful to know more about this because you can't avoid using it in some cases. Having more details would help us make better management decisions because we would better understand the cost benefit equation. That's a great comment, Tony, and one that I completely agree with. The reality is that managing the soil microbiome for the last 40 years, well, since forever, really, has been in some ways more art than science. There is so much about the soil microbiome that we simply haven't quantified, that we don't know. And uh, I'm quite excited some of the efforts that we're putting in place to get a soil DNA lab established here with Dr. Laura Kavanaugh's work here at AEA. We will be able to actually measure the impact, not just of glyphosate applications, but also of fungicide applications, of tillage passes. Let's actually see how the soil microbiome changes before and after. And I expect we'll be surprised by some of the things that we discover because it's a largely unexplored frontier at this moment. We don't know what is the effect of a single tillage pass? What's the cumulative effect of multiple tillage passes? What are the effects of glyphosate applications? We now stand on the threshold of being able to shift these conversations from somewhat theoretical conversations where we can observe some downstream impacts to actually being able to measure exactly what's happening with the soil microbiome and then hopefully also better understand what it is that we need to do to compensate. If we're in a position where we feel there is no alternative other than to use glyphosate, then okay, how do we compensate for that? What exactly do we need to do to shift the soil microbiome back to a healthier state after using glyphosate? There's a lot of research and a lot of homework that needs to be done to identify and understand all of that. Question here from Jesse. Using 1 ton of quality chicken litter to replace my 2x2 dry fertilizer application, how can I help manage the nutrients in a no-till operation so that they can be more plant available? Well, Jesse, I'm not sure exactly the question that you're asking, but if you're applying them in a 2x2, I would certainly think, oh, sorry, you're replacing your 2x2. So just pretend that chicken litter is fertilizer. If you want to get good nutrient availability and good nutrient delivery, then it's about positioning. And where you're positioning your other fertilizer in a 2x2, why not position your poultry litter in a 2x2? Or why not position it underneath the row? You need to get it into the root zone. Because if you're in a no-till environment and you just broadcast it on the soil surface close to planting, then you're probably not going to get the best nutrient release in a timely manner. Maybe that means you need to apply it 30 days ahead of planting. Maybe it means you need to band it. I don't know enough about your local context, but it's the question you need to think about is how can you get it into the soil so that can be worked upon by biology and be made quickly available for the plant. Question here from Ian. We're growing in Arizona in a diverse crop market farm setting. We top dressed about a foot of bulk compost when first installed the farm about 5 years ago. Initially, we were reviewing nitrogen deficiencies, so we added chicken manure to balance out. As time has gone on, our compost has dropped about 4 to 6 inches. We are now seeing extremely high nutrients in the soil, giving us lots of insect pressure and inhibiting plant growth. Oh dear me, Ian, this is a tough scenario here. So, yeah, what you're describing is an over application of compost, whether that's coming from mushroom compost or whatever the case might have been. So what you will be experiencing and be seeing is very high levels of phosphorus and potassium to such a degree that you're probably causing nutrient deficiencies of other elements. Um, and quite likely you're not seeing high enough levels of calcium, almost certainly. And so um, the general approach that I would recommend is applying a combination of carbon and calcium. So carbon can mean different things. It can mean lignite ore, as in humates. It can mean biochar, although I would advise caution on biochar. Um, and in terms of calcium, you might use a little bit of gypsum to provide some sulfur, but in order to buffer out the high levels of phosphorus and potassium and just the general nutrient excess that you have, you need to take a look at some significant applications of calcium carbonate to balance that out and to buffer that out. So that's the general approach. To give you more details would need some specific analysis to know exactly what's happening and what's going on. But the combination of carbon and calcium can buffer out those nutrient excesses and help you turn the corner to having very healthy crops. The good news is that as you build calcium and carbon levels, you have the nutrient foundation that you should be able to produce some remarkable yields of very healthy crops. Lots of questions have come through here. Um, what do you think about fish stabilized with phosphoric acid as a quick foliar phosphorus source for organically certified operations? A nearby vendor is selling an organic liquid 140. It's generally a good source. Can be a good source of phosphorus, but obviously the concentration is very low. Um, yeah, liquid fish is. I made the comment once at a conference years ago and received some interesting reactions for my comment. But I said the problem with liquid fish is that it's a good product. It's not a great product. It's a good product, and it's a good byproduct. It's good that we are reusing it and repurposing it. But many liquid fish products are what I would call low horsepower products. They're not bad, but it takes a lot of them to do a good job. And so that's it's not that I'm not a fan of liquid fish. We make lots of recommendations for liquid fish because it's a resource that's fairly readily available. Um, but I'm of the persuasion that in many cases there are better tools out there to do specific things that we're looking for. Question from Josh Thurman. Hi, Josh. Good to see you here. Um, let's assume you are addressing a crowd of fundamental industrial agriculturists in a broadacre system. Well, you really want to throw me to the wolves here, Josh. Not at all. I'm joking. Um, you have 5 minutes to pique their interest. What is the pronounced statement or the resounding sentiment that you are wanting them to understand? Well, Josh, it would depend. It would depend on what crops they're growing. I would talk differently to a group of people growing corn and soybeans than I would to people growing cotton or to growing fruits and vegetables. But in general, um, I'm just realizing that I do customize what I talk about a lot. But in general, I ask myself the question, how can I bring the greatest value? How can I bring the greatest value to this particular group of people? What information can I share with them that will be most helpful and most beneficial for them? And um, in some cases, the answer to that question is showing them how they can improve harvest quality. So improving harvest quality on cotton is kind of a big deal. Improving harvest quality on fruits and nuts is kind of a big deal. Corn and soybeans, maybe a little bit, but not so much. And so what I've found interesting over the years, I'm kind of taking the long way around the mountain of answering your question here, but what I've found interesting over the years is that um, when we talk about improving soil health, or growing crops that are resistant to diseases and insects, and eliminating the need for pesticides, and growing food that has nutritional integrity and that can be described as food as medicine. Many growers they're interested, they're intrigued, they would like to learn more, but it is an exceptional grower that would use that information as the basis for making a decision to do things differently. The amount of potential reward doesn't exist in the marketplace right now for those things, and yet the perceived risk or the actual risk from making management changes does exist. So the risk to reward ratio is lopsided there. And so for the last decade plus, our tagline in our work at AEA has been very simple and very straightforward. We help you make more money with and be more profitable with regenerative agriculture plant nutrition management. We manage plant nutrition differently. The reality is we work on many very conventional mainstream farms that have no aspirations of being particularly regenerative, but simply by managing nutrition differently, timing nitrogen applications and potassium applications, putting them on at different times and perhaps in different amounts, fine-tuning their agronomic management with sap analysis, we're able to save them a tremendous amount of money on inputs while increasing yields at the same time. This is very common. It's, I've been an advocate for sap analysis, and um, they're expensive. They're 2 or 3 times the cost of a tissue analysis. And sometimes growers will complain about the price tag associated with sap analysis. And then in a few months, we'll realize that actually we've saved tens of thousands, or in some cases, hundreds of thousands of dollars. We had one operation just recently. Over the course of 2 years, we saved them $1.5 million on nitrogen and potassium inputs that they realized with sap analysis that they did not need. They had historically been applying in excess, but they never knew. They didn't realize they were applying excessive amounts because they had no data to indicate that. So our pitch is quite simple. We help you make more money by managing plant nutrition differently. And that means different things for different crops. Some crops, it means reducing inputs or positioning inputs differently. In other crops, it means improving yield, quality, and performance. So I'm giving you a very broad kind of generalist perspective and answer here, but that's the way that I would approach the conversation. Kristen asked a question. You mentioned that you would be careful of biochar. Can you elaborate on this? Yes, I can. 2 thoughts. One that I have a deeper perspective on than another. The perspective that I have, where I have the most experience, is I have looked in vain for a significant yield or crop quality response from biochar. I can't find it. We've worked with many growers who've experimented with biochar. We've done extensive soil analysis. We've looked at sap analysis. We've looked at yield data. On some fields, we've seen improvements in fungal populations where biochar was added. And I'm not just talking about biochar as like people have been doing good things. They've been adding, they've been charging the biochar by adding microbes to it, mixing it with compost. They've been doing lots of different things to improve the quality of biochar. I do not see the field performance. I don't see improvements in soil health, and I don't see improvements in performance in plant health. And I see a significant sticker price for the farmer. And therefore, it's not a recommendation that I'm comfortable making. That's the one that I have personal experience with. I don't have deep personal experience, but I've heard people talking about how biochar has a very alkaline pH, and depending on the source and where it's coming from, can have very high concentrations of toxic elements. And so I'm not saying that that's the case universally, but I do think we would be wise to exercise caution. And the question from a grower perspective, if we're looking at it from a commercial farming perspective, where's the return? I don't see the return. And therefore, it doesn't make sense. If it doesn't make economic sense for the grower, if we're only going to apply to the soil for the carbon credits and the feel good benefits of the economics of being able to sell carbon, well, the returns aren't there for the grower either. Other people are benefiting more than the farmer is benefiting, and so that's my foundational criticism that I would level at biochar. Question from John: when applying Santerra, should we use the same application method as you recommend for the spectrum application, also applying Sea Shield and Rejuvenate? Yes, it does perform better when it's applied in that combination, but it's also very resilient and can work on its own. Good question, John. Um, Follow-up question from Cole. My soils are low in molybdenum, 1 to 1.5 part per million on the nutrient analysis of 0 to 6 inches. It's showing up in extreme deficiencies on sap in my corn and soybeans. Should I apply an amendment to try and raise soil levels? And if so, what is the best form? Or should I just try to correct deficiencies with foliars and count on cover crops and cash crop roots to find it deeper in the profile over time? Central Indiana context. It's a great question, Cole. I'm trying to think right now if the total digestion analysis measures molybdenum. I'm sure you could get it measured. And it would be interesting to measure just what are your molybdenum reserves deeper in the soil profile. But in central Indiana, in a high rainfall environment, it's a reasonably good guess to also guess that they're probably quite low. So it is possible to address molybdenum as a soil amendment. You would be looking at using sodium molybdate. And when you are using that, I mean, it's the downside of molybdenum as a soil amendment is that molybdenum is an anion, just the same as nitrate and sulfate and boron, and it leaches through the system. So in order to hold it stable in the soil, you need to have the way to hold it stable is with carbon, is with organic matter. And so I would more suggest you can use it as a soil amendment, but I would consider spoon feeding it year by year as we do sulfur and boron, rather than expecting we can do a single application and expect that to last for the long term, like we're able to do with other trace minerals like cobalt or zinc, for example. So that would be the caveat that I would offer. Question from Tony. Follow-up question. Any general advice for regenerative management of river bottom floodplain corn, soybeans, milo? Currently using ryegrass for cover crop due to its flood tolerance. Usually doesn't flood until late winter or spring. Tony, I think you're already doing well by making sure that it's if you have a good ryegrass cover crop that's really holding onto that soil. Trying to think the other types. Again, I don't know where you're located geographically, Tony. I'm not sure exactly what makes sense from a climactic perspective, but what about seeing if we can add some diversity to that annual ryegrass with other types of plants that will also thrive in that environment, possibly even rice. I don't know. Again, I'm missing a lot of context here. I don't know the details of what it is you're working with, but I think you're doing things well already. I would just try to add some diversity to that ryegrass mix. Question from Benina. Hi, Benina. I caught the tail end of a comment about liquid fish and wanted to learn more. In organic farming, we are limited on nitrogen sources. What sources of nitrogen do you recommend for organic tree crops? Well, there are a number of sources available today that weren't available even a handful of years ago. We now have both liquid and dry powder amino acids, such as, we've got soybean hydrolysate, we have corn steep liquor, we have several of those types of materials, sources of amino acids. But Nina, I wanted to get into a deeper conversation with you about nitrogen supply for your trees that we haven't gotten to yet. Our experience historically has been that when we use our soil primer with the Spectrum and Rejuvenate combination, that we get very strong nitrogen delivery, even to the point where we have some of our operations, we have excess of nitrogen supply just coming from biological fixation. So we need to figure out and find out if that is happening for you, and if not, why not, and what is it that we need to shift to get that to a different place. Question from Charles: have you done any work with bokashi? What are your thoughts on using the fermented product directly in the planting location for the final breakdown? Um, so I've done limited work with bokashi. I've observed a number of other people who've done work with bokashi and various different farms, and I've been very impressed with the results. I've been very impressed with the reducing effect that it has on the both on the soil microbiome and also on increasing trace mineral availability as a result of that reducing effect. And to your second question, what are your thoughts on using the fermented product directly in the planting location for the final breakdown? I don't have experience, so I don't know. But because it has such a strong effect on the microbiome, I would suggest using caution in putting it in too close proximity to the root system. I would rather have it separated by a little bit of soil, put it on the soil surface, or put it around the root system. But I would exercise some caution about getting a lot of direct soil contact with large amounts of bokashi. A question from Mr. Redneck. That's an interesting username. What is your nitrogen recommendation for upland cotton based on pounds of actual nitrogen per bale per acre in Texas Southern High Plains? I don't have one off the top of my head because it's not about pounds of cotton per bale. It's about the pounds of cotton required to get good root system establishment early on. And then there's, of course, fill required later. But I'd have to look at specific numbers of what we are running. Off the top of my head, I would say we're probably, again, there's lots of variation here. We've got one grower that it comes to mind that we're working with that is putting on no nitrogen, other than, well, no applied straight nitrogen. He's putting on a couple tons of compost per acre before planting, up to 60 units. I'm sure there's a few growers that we're working with that are higher than 60 units of N. So I don't have a number for you off the top of my head, but I do know that the timing and the location and the type of nitrogen to get the greatest crop response is very important. And also that a great deal of the need for continuous PIX applications and constant applications of PGRs is because of misapplication of nitrogen. So you can actually you can really shift the way that a plant is expressing and behaving itself with nitrogen management. Question from Danielle. I have high pH calcareous soils and phosphorus, and micronutrient availability is a continual issue. Yes, it would be. What is the best solution? Location is in northeast Nebraska. So, Danielle, the best solution depends a bit on scale. So, high pH calcareous soils can mean there can be quite a range of severity of the degree of high pH and the degree of free limestone particles. So there's a few thoughts that come to mind. One is if it is economically viable with the crop type and crop mix that you're growing, um, using elemental sulfur as a fertilizer can be a very valuable tool. And when I say elemental sulfur as a fertilizer, actually let me clarify that. So obviously, elemental sulfur as a soil amendment effect per, to introduce some local acidity and to increase calcium availability. If you have high concentrations of limestone, free limestone particulates, then in order to make the amount of elemental sulfur required economically effective, you need to band it. You need to concentrate it in the root zone. And of course, to do that, um, you have to be cautious about putting it on at the time of planting. You need to be looking at strip till or somehow getting it out there in advance so it has a little bit of time to react before you plant. So there's, depending on the context and situations, there's some of the upsides and downsides there. The other thing you should think about is growing crops and or cover crops that have a particularly acidic root system. Two that come to mind are buckwheat and oats. And I'm sure there are others that I'm not thinking of right now. But some of these plants have root exudates that have a pH of 3, and they are very acidic, and they can actually go quite the distance in remediating some of the free limestone particulate matter, particularly if done multiple years in a row. It's possible to produce some substantial changes in soil pH levels and soil-free limestone particulate matter. So that would be one of the things that I would, from a long-term fixed perspective, that would be the place that I would look. Um, Question here from Hayden. Could you explain what Biocoat Golden Seed Flare alone, without any other nutrients added, could do for me when grazing cover crops? Well, Hayden, the way that I would answer the question is that Seed Flare and Biocoat Gold are specifically designed to have very strong root colonization and root development and good establishment right at planting, so that the plant really takes off with a bang. So um, again, I'm missing a lot of context here, but I know in the case of, see if I can remember this correctly now. It's been a while since I looked at the data. If I recall correctly, cotton germination time got cut by about 30%. Wheat germination time, in the case of a wheat grower in Washington that we work with, got reduced from 3 days to 24 hours. So the speed of seed germination and emergence can be greatly reduced, and that usually translates to a lot more vegetative biomass. And so, from a grazing perspective, you should be able to benefit simply from having plants that have larger root systems that get off to a stronger start and therefore producing more yield. So, that's the place that I would begin. I think we've got time for one more question, and then I'm going to have to call it a wrap here. Question here from Harrison. Do you have a more in-depth instruction or overview of how to start switching a program from tissue analysis to SAP analysis? How many samples per field, subsamples, timing, etc.? This is a really great question. Here's my recommendation. There are two different ways of approaching it. So I would think of it in terms of, first I would think of it in terms of management units. What is it that you're actually going to manage separately? So if you have 20 different blocks of canola or wheat, but you're going to manage them all the same, they're going to get similar foliar applications and similar soil applications, then why measure them separately? So think about how your management units of what is it that you're actually going to manage differently. Next, you can think about when are you going to be making management decisions? So, for example, if you're putting on an insecticide or fungicide spray, you're making a field pass anyway, you're interested in doing foliar applications. If that happens 5 times in a growing season or 3 times in a growing season, think about pulling SAP analysis information 2 or 3 days, let's say 2 weeks before you're making that application, so you can make an informed decision on what it is that you're going to apply. So those are two ways of thinking about it. But those two are very practical from a management perspective, but they are, in my opinion, the least valuable from a learning and from a long-term information perspective. The most valuable method of all is to identify a couple of representative blocks, representative fields, and measure them consistently from the earliest possible opportunity, the earliest plant stage at which you can collect leaves to sample, all the way through until harvest. You do that every 2 weeks throughout the entire growing season. And if you have 30 fields or 50 fields, I don't care. Do it on 3. Do it on 10%. Do it on just a couple. You will learn more about how nutrients are moving around in your soils and your plants than you can ever hope to learn by only pulling 3 samples per year. I see many growers make the mistake of deciding, well, I don't have the time, the help, the labor, the resources. I can't afford to pull samples every 2 weeks. And they get 2 or 3 years down the road and they say, wow, I've learned so much from sap analysis by just pulling 3 samples per year. I think I need to start pulling a sample every 2 weeks. And they pull a sample every 2 weeks. And invariably, I have never yet had a grower say, I'm going to go back to doing it only 3 times per year. They always say, wow, why didn't I do this from the very beginning? Because all of a sudden, there is so much additional information revealed. And that's also how the additional information is revealed that provides the greatest savings in fertilizer costs, is when we are seeing that, in fact, the product that we are applying is releasing not at the moment when the plant has the most need, but either before that or after that. And that in spite of us applying large amounts of potash, our crop is deficient in potash during the grain fill period. Or in spite of us applying large amounts of nitrogen, our crop is deficient in nitrogen during the grain fill period. The most expensive problems or the most expensive mistakes that most growers make is applying the wrong product I misspoke. The most expensive mistake that most growers commonly make is applying the right product in the wrong amount at the wrong time. It's not that they're doing the wrong things or applying the wrong product. It's the right product, but it's not being properly positioned. And a sap analysis every 2 weeks reveals that like nothing else can. That is the value of being able to see the trends and to see how nutrients are moving through the growing season. So I think we're going to call it a wrap. I want to say thank you all for being here. I hope you found the information valuable and useful. I look forward to doing more of these again in the future. May your growing season be awesome. May the rains always be timely. And may you have an awesome day. Thank you all for being here.